Aloha, ITS128, and today is September 10th. And so today I'd like to continue on with Chapter 3. And so let me share my screen. And let me log into Laulima. And we are 128 Fall 20. And so we are, today is September 10th, which is like, we're going to do these, we're going to do the challenge activities, more challenge activities for Chapter 3. All right, so if we look at, what I'm going to try to get through today is, okay, I've checked off just the challenge activities, and they look like this. So we're going to do these. There's coding challenges, and then there's these progressions too, and I might as well. They're all good practice. It just, if you just do all of the participation activities, and I was looking at some of them, and you click around, and I'm noticing how many times you have to click around before you get the points, a couple times, and if you do all those, when it comes time to actually do these coding challenges and then write the programs, it's like right at the top of your head. It's like you don't have to refer back to anything, and it's a nice way of learning this stuff by reading a little, doing a little bit, reinforcing, reading, and so on. All right, so so let's go to Chapter 4. I'll just put this down here. And so I'm going to go to Chapter 4. Let me go back to here. I'm sorry, Section 4, Dictionary Basics. Okay, so you recall last time we learned about lists and how they can be ordered, and we learned about sets, and they have the same stuff as lists, except for sets are a little different. They're not ordered. So we have creating a dictionary. A dictionary is like a list, except for with a list you refer to the items in the list by their index. The order starting with counting with 0. With a dictionary, each item has a name. So it's a name value pair, as they say, or a key value pair, sometimes they say. So so to create a dictionary, for example, we would do this. Let's create a dictionary called players, and we're going to have 2 of them in there, and there's going to be a value, whatever this 10 is. They're jersey numbers. Okay, so Lionel Messi is number 10, and okay, so 10 and 7, and so this is the name, and then this is the value, or this is the key, and this is the value that's associated with the key. All right, so and then when you print them, it prints out nicely like this in Python. Okay, so so here's an example of where we've created a bunch of we created a dictionary called caffeine content milligrams, and we have a bunch of items in here, and then when we print this all out, let's run it, and we see that it just prints out like that, just the way it's defined. So using braces, create a dictionary called ages that maps the name Bob and Frank into their ages 27 and 75 respectively. So I make Bob the first entry. So you just say ages equals and do a curly brace, and then you do a single quote Bob, and then you do a colon, and then you do the value, which I guess is 27, and then you separate the next one with a comma, just like I'm looking right up here, see. And then we got Frank in quotes, and then colon, and then the value is 75. And then you close up that, you close it up with a ending brace. And so it looks like that. And so the way you can access these dictionary items is just like if this were a list, you would say prices of 0 and prices of 1. Well, instead, each item has got its own name, and so you say price, and so you can just call it by its name. Prices of apples and prices of lemons. Oops, of oranges. Error. Okay. Anyway. So dictionary is because this is trying to display out lemons, and this is trying to display out images. I don't know what the purpose of showing this error. Well, it's just showing a runtime error because there is no key. There's no price. There's no key lemons in the prices dictionary. You can add an entry just by saying, you know, it's students. There might not have been a student named John, but all you have to do is do an assignment like this, and it creates a new entry named John, and you add and this is the value. And if you want to update, let's say Jessica, students of Jessica had a different grade, and you just wanted to update it, then so that's how you do it. Same way, assignment statements. And then this is how you would actually delete an entry. So this creates an empty one, and then this adds one of them, and then when you display this out, it just displays out the first one. This, I guess, yes, this. And then when you add this, overwrites it. See, this would change the value of prices of banana to 169, and then this deletes it. Okay, so anyway, let's get to these challenge activities here. All right, so here we have a dictionary. It has 2 cars in it, and presumably it's wherever headquarters or where they're made or whatever. And probably not where they're made. Probably where their headquarters is. Fiat is not Egypt, though. When we print out so when this thing executes, okay, so we're supposed to put some code right there. And when this thing executes, we want it to print out where Acura is made in Japan, Fiat is made in Italy, and Tesla is made in the USA. And so we have to make the dictionary have these values. 3 entries, and Acura has got to be equal to Japan, and car makers of Fiat's got to be, and so on. Well, we have here Acura is Japan, so that's okay. We can leave that alone. Here we've got Fiat is Egypt, and we want to change that to Italy, so we would just go something like car makers of Fiat is actually equal to Italy. Of course, these cars are made all over the place now. So. And then this last one, Tesla in USA, it's not even there, so that's a new entry. Car makers of Tesla is equal to USA. And then this, so I'm quite sure this is correct. You can click run and see that it's correct. All right, so that's this coding challenge, isn't it? Okay, so let's buzz through a couple of more sections here, and we can get to the type conversions. Okay, so here we're talking about common data, a summary of the common data types. Okay, so we know about integers and floats. There's sequence types, strings and lists and tuples. Yeah, strings. Oh yes, strings and lists and tuple. I keep forgetting. Tuple in this language is sequence, but in other languages it's not. It's like a set. But, it's like a dictionary actually. Tuples in other languages are like dictionaries, and yes, they're not ordered. So anyway, and then the only mapping type in Python is the dictionary type, the Dict type. And like a sequence, the Dict type serves as a container. However, each element of a dictionary is independent, having no special ordering or relation to other elements. Dictionary uses key value pairs to associate a key with a value. So we have strings, and then we have lists, which can be it's a container, and it's a container of ordered elements, and these elements can be strings or integers. You know, they're floats. These are primitive types. These are like primitive types, and then we have these lists and these tuples and these dictionaries. And a list is a container with and it's mutable, which means you can change it. It means it's changeable at runtime. And a tuple is a sequence. It's immutable, which means you can't change it. Once it's defined, don't change it. And then this dictionary type is a mapping where you have key value pairs or name value pairs. So this, here we are back to, can you mix? I think you can. No, can't mix them. The list contains a mix of integers and strings. List can oh, no, never mind. I meant to say false. I said the list is valid. Okay, so anyway, yes, a list can contain mixes of types. That's what I thought. Int and float types can also hold the exact, int and float types can always hold the exact same values. A float, floats can hold ints, but ints can't hold floats. I mean, there are floats that can't be held in an int. Yes, because you can have a decimal point. A sorted collection of integers might best be contained in a list, not a set. A list, yes. Choosing a container type, okay. Student test scores may later be adjusted, ordered for the best and worst. A list, because a list is ordered and it's mutable. A tuple is ordered, but it's not mutable, and a dictionary is not ordered either. Single student's name and their final grade in class. Well, that sounds awfully like a dictionary. Well, I was going to click this. Oh, single student's name and their final grade in the class.
Tuple?
Yeah, tuple. Okay. A bunch of tuples. All right. Yeah. When is the grade final? Well, you know, I just had a case where it was it's a class I teach at Manoa, this database class, and I had this one student who kept taking the class, and he could never, like, he had a lot going on in his life, and I could tell he'd been a student for years and years. I could tell by his email address. a UH student for probably as long as I've been around. But anyway, so he's taken my class, and after a while I said, well, I tell you what, why don't you just take the class and you don't have to pay, and I'll give you a change of grade at the end. Okay, so he didn't, so you know, the incomplete period was long gone, and so lo and behold, one semester, about two semesters ago, he like got everything done. He just emails me, okay, I got all the stuff done, and I, you know, it's like I wasn't really prepared for it. So, well, so anyway, so I submitted a change of grade, and my department chair said, this is like 3 or 4 years old. I can't sign this. And I said, okay. And so, you know, fine. I just go back and tell the student, well, I'll tell you what, all you got to do is sign up for it next semester, and I'll kind of apply all this work that you did to that, and so we can get you through this, okay? But the worst thing that might happen is you might have to sign up for it again, and you're going to delay, or because this was keeping him from graduating, you might delay another semester. But then my department chair says, but he can contest it, or he can submit, or whatever, where you challenge the decision. He can appeal. That's the term. He can appeal. And so so I said, okay. So I emailed him and I said, okay, but my department chair says that you can appeal. And so appealing involves just filling out this form and sending it up to the dean, and the dean looks at it and goes, appeal is granted. Okay, so then I get back an email from my department chair saying, okay, well, his appeal was granted. You're gonna have to submit the change of grade again because we got rid of the last one. And so it's kind of like, you know, no one really, I mean, everybody just followed the standard rules, and the department chair did what he had to do and what he should have done, and there was nobody really upset or anything. But anyway, so what does it mean to have a final grade? Well, I don't know. A final grade is, it's like maybe you know, after you graduate or something, or, you know, after you die or something. So anyway, that's just a sort of a side story there. All right, enough side stories. Okay, so click on the our student grade pro. What am I supposed to do here? Finding errors in the container code. Okay, so I got a students equal that. Name equals, so it prompts you. By the way, this is prompting. Do we know about prompting yet? I don't think we do. Name, grade, and then we, it has to do with the, oh, well, I'm just going to click on this. No, it's correct way to make a list. Corrects that. This is, dictionary does not use an append function. Okay. Oh, okay. Dictionary doesn't use the append function. Right. Right. That's right. Okay. Forgot. Okay. And by the way, look, I got the points. This is not the right way to make a list, right? No, it's the correct way to make a tuple, though. Okay, they're making a tuple. You can't delete? Yeah, tuples cannot be modified. Okay, great. Now, okay. Anyway, let's move on. All right. See, this is a time is it? 3:40. It's supposed to 4:30. All right, you can work on that. Let's go to the next progression. Let's go to that one. All right, type conversions. Okay, here Okay, so there's implicit conversion, which is the obvious thing. If you mix an integer with a float, the result is going to be a float. That's implicit because you're mixing. But otherwise, you got to say what you're you have to use a type conversion function to change it, if you want to mix. You have to tell it the conversion. In other languages, there's always a default, but in this language, you have to tell it. So for any floating point answer, type okay. Okay, type the value held in the variable after the assignment statement given. Okay, number of items is 5. Item weight is, what is number of items? Oh, number of items plus number of items is, I guess it's 10. Yeah. Item weight times number of items, well, that would be 5 times 2.5. And number of items, okay. Oh. I don't know, 5 points, no, 5.0. Yeah. All right, okay, so these are the conversion functions, methods. So this function can convert, well, it creates an integer. This converts something to a floating point, and this converts something to a string. So here we input a number, and in this example it's 18, and that's a string. It's going to be a string. Then here this converts it to a floating point number, and then this prints it out, and you know, there's an implicit type conversion here, because here you're printing out a number, and really you print strings. So same here. What is the result of each expression? One. I guess it's this. Okay, here's a challenge. So, okay, start. Type the program's output. 1 times 2 is 2. 2? Oh, that's a pretty tough one there. All right, what's next? Number. 4.0, maybe. And this one would be 6.0. I think. 2. And this one is 1.0 maybe. And this last one is, this reads in a string, 8 point, an 8, a decimal point, and a 7. This converts it to 8.7. And then this converts it to 8. So number string, okay, so first we print number string, 8.7. And then we print the number as a floating point number, which would be 8.7. Yeah, okay, 8.7. And then we take that 8.7. No, then we take that 8.7 and then we integerize it, and we get this, and we print that out, and that just hacks off the 7, so we have 8 without a decimal point. Okay, here's a nice challenge activity. Oh. Let's see. All right, so average owls per, assign average owls with the average of owls per zoo and print it as an integer. So, okay. Well, you can just go like this, I guess. No, I'm gonna fool around a little bit with this. I'm gonna see what time is it. 3:46. We got 45 minutes. We have a lot of time actually. So let me open up some sort of. Oh, here's a. And I'm gonna make this a Python program, and I'm gonna copy this into my Python program. Copy. Paste. And I'm going to okay, I'm going to save this as test.py on my desktop, and then I'm going to get there, open a command line prompt, cd desktop, and I'm going to Python test.py and see what happens first. Oh, and it's asking me for an input. 2, 3, 4. Okay. It's because it wasn't calculated. It's set to 0. Okay, now what I'm interested in is what happens if let's do this. I'm going to go average owls equals num owls of zoo A plus C and B. And then I'm going to do AVG owls equals AVG owls divided by 3. And then I'm going to print this. I'm going to leave that int off there, and I'm going to save this. And I'm going to run this and see what happens. 1, 2, 4. Okay, 2.3. It prints out as 2. Okay, so this does actually. I'm doing all inner. Oh no. Oh no, this. Okay, if that matters. Okay, I'm gonna try this. One, 2, 4. Oh, same thing. Okay, so this is an integer. I'm typing in numbers. I'm typing in strings, and they're being converted to integers. I take an integer plus an integer plus an integer, and I get an integer. And then I take that integer and I divide it by an integer 3, and all of a sudden I get a floating point number. Because when I print it out, it's a floating point number. Well, what do you know? I bet if I do this, is this the language where I can do that and it just gives me the 1, 2, 4. Oh yeah, okay, that works that way. Okay, well, if that works that way, you know what I'm going to do? I'm going to try to copy this. See, because really int, it should be int, the thing goes like this, int that, and that, and this is probably what they mean by an answer. And that's going to print out 1, 2, 4. That's going to print out what we want because we're integerizing it right when we print it out. But what happens if we do this? It's going to give the same answer, 1, 2, 4, but I wonder if it will accept it. Copy. I wonder if it'll accept it as an answer. Run. Looks right to me. Got all the points, I guess. All right. Well, anyway, the right answers. This is, well, they could be looking for this, actually. This will work. Divided by 3. Don't even need this. Does it say you're supposed to do it in one line? No. Okay. So this is a good answer there. All right. What's next? Oh, another challenge activity. Okay, here in this one, we just have these strings here. So we want to, they have to be converted. So they can be converted in the expression in this statement. Owls equals int of num owls A plus int of num owls B parentheses divided by 2. Huh? Oh, wait a minute. Oh, I'm just supposed to sum them, aren't I? I'm just supposed to sum them. What am I doing here? I don't need to put the parentheses here then either. Do I? All right. Okay. What's next? Binary numbers. Is there a thing on binary numbers here? Ah, there is. There's a progression. Okay. Well, you should remember binary numbers from I don't know, ITS128. I think they talk about binary numbers. All right. So, you know, numbers. You know, decimal numbers. When we talk about decimal numbers, like let's take this number 212. Really, this is, you know, 2 times. They shouldn't have used 2. They shouldn't have used 212. They should have used some other numbers. Okay, this 2 is this leftmost 2, and then this 1 is the one in the middle, and then this 2 is the rightmost 2. So it's 10 to the 2 power, 10 to the 1 power, 10 to the 0 power. And so if there were more digits, it'd be 10 to the 3, 10 to the 4, 10 to the 5, like that. And of course, 10 to the 0 power is 1. 10 to the 1 power, 10 to the first power is 10. 10 to the 2 power is 100. This is how many zeros. The decimal point is the number of, the exponent is the number of zeros after the 1. See, so anyway, so it's 2 times 100, which is 200, plus 1 times 10 is 10, and so that's how it adds up to 212. Well, the reason this is a 10 is because we do things in base 10. You know, we have 10 digits, 10 single digits at 0 through 9, and then after that we start combining them, you know, to bigger numbers, to larger values. Well, in base 2, there's just 2 digits. There's 0 and a 1. And so it's 2. So it's 2, not 10. So it's 2 to the 0, 2 to the first, 2 to the second, 2 to the third. So 1101 is this one is 2 to the 0 place, 2 to the first place, 2 to the second place, 2 to the third place. And so it's 1 times 2 to the third, plus 1 times 2 to the second, plus 0 times 2 to the first, times 1, or plus 1, plus 1 times 2 to the third, plus 1 times 2 to the second, and so on. And so what these powers of 2 end up being is, each time it doubles, so 1, 2, 4, 8, 16, 32, 64, and so on. So a byte is 8 binary digits, and so it's easy to convert. If you just have this, well, this here makes it really easy to convert. So like the number 20, the number 20 is going to be 16 plus 4, right? So 16 plus 4 is 20. It's 1 times 2 to the fourth plus 1 times 2 to the second, and that equals 20. So anyway, convert the binary number this into a decimal number. Well, we can just use this up here. 1, 1, 1, 0. Okay, so 0, 0, 0, 0, 1, 1, 1, 1. 0, 0, 0, 0, 1, 1, 1, 1. Why? It's 15. Convert this number. So this is 128 plus 16. 128, clear all this out of here. 128 plus 6, no, plus 8. Oh, sorry, 8. 136. All right. Convert the decimal number 51 to an 8-bit binary number. Well, let's see. There's a 32 in there. There's a 32 in there. Okay, it would be, well, we can just, okay, so it's 32 plus 16 is 48. 32 plus 16 is 48. 8, 4, 48 plus 4 is 52. That's too much. See, this is 32, 16, 8, 4, 2, 1. So it's 32 plus 16 equals 48, plus nothing. 32, 16, not 8, not 4, plus 2, that equals 50, and then 1. Anyway, that's what it is. Create a binary number. Match the decimal value. Match. Oh. All right, nice. String formatting. We've done this. Now we're going to do these string formatting ones. This is tricky stuff. This is the weirdest formatting of any language I've ever met. But after you learn it, it makes sense. I mean, most of them are kind of weird, actually. All right, so this time we're going to talk about this format function, and it's how you format. Like here, you've got. Let's say you want to say, 6 burritos cost $32. $32, I guess. So how do you print and format that out? Well, you can always do this. Number equals 6. Amount equals 32. You can do print number burritos cost oh yeah, you'd have a problem with this. There's going to be a space amount. So you could have that, but the trouble with that is you run it, it looks like that. You have a space there. Well, so you could instead do outstring equals number plus space burritos cost $, quote, plus amount. And then you can just print outstring. Okay, that'll do it. Do I have to do this? Wait a minute. Yeah, right. Right. Does this work? Yes, okay, so I can do it that way. Kind of complicated. Or I can do it this way, where we use this format function right there. And what the format function does, get rid of this, is we wanted something, parentheses, it's something dot format, and we're going to print out the number first. It doesn't matter first or second. Number, and then the amount. And how are we going to do that? Well, we're going to have a format here, and it's going to be enclosed in some quotes. Okay, enclosed in some quotes, and we use these curly braces here to identify, you know, and this is the simplest way to do this, the simplest version of format. The first empty curly braces refers to the first one, and then the next one refers to this one. See, so we can do that. So basically, we're just going to do whatever the first one is, burritos cost $, and then whatever the second number was. And this will do the same thing. Yeah, 6 burritos cost $32. It's pretty expensive for burritos, man. Okay, so it's called a replacement field. Now, you can also use numbers. Positional. This is what we just did was inferred positional replacement. You can do positional, okay, non-inferred. So let's say we like to do things in alphabetical order or some crazy thing. It's because Notepad is the worst editor there is. Now, this is a problem because Of course, it's going to reverse the thing, reverse the numbers. Oh, not format. I meant amount. No, I meant amount. Silly. $32 breeders cost $6. That's a little bit better, but so we got them reversed, so we can just do 1, 0, because this is the 0th one and this is the 1th one. This should work. That's better. All right. Oops. Okay, so or you have named replacements. Named replacements look kind of like name value pairs, don't they? So and they are. They can be in any order. So we want to print out the animal in the headwear is whatever shape it is, and so over here where the arguments are, the arguments. It's not inferred positional. It's not positional at all. It's actually named. So we say the animal, wherever the animal shows up over here, that'll be equal to cat. That'll be a cat, and the headwear will be a hat, and the shape will be fat. Named replacement allows the programmer to create a keyword argument that defines the name and value of the format by arguments, a parameter argument. So now you have to make one thing is you cannot mix positional and inferred, positional and inferred positional. You can't mix them. These one or the other. However, you can mix named and either of the positional ones, but you just can't mix positional and inferred positional. Okay, so here's one way of first name. So this is going to be Card's last name is B. Cardi's last name is B. Here you're going to have first name. Oh, yeah, right. B's first name is Cardi. And here it's right down here. Cardi B, more like Cardi Z. All right, so these are just examples of using named replacement, positional, inferred positional replacement, and positional replacement. So you can do these. Determine, what is this? I see. So here they're just showing you that you don't have to, this is like a literal. This is like a literal. Well, you can define a variable. That's this string, this literal string here, and then you can and then that can be used as along with the format method. So there's no reason why I see no reason why you can't do that. All right. So here you're printing out date. It's going to be simply April 22nd. 2020 and April 23rd, 2024, enter. Really? Really? Okay. Sure. Get there. I don't know why it shouldn't have that there. It seems like this is just a plain old print. It doesn't say end equals. I mean, they're saying it's. That's weird. Really. So they're saying they're actually doing this. I mean, that's what they say. They say it's really that. Wait a minute. Did I save this? Yeah. Well, anyway, I think this is the wrong answer. Anyway, all right, format specifications. Okay, so there's a little bit more to this, and that is we can there's also formatting. The formats, these are called a presentation type, I guess. Integers for this precision. Okay, so a presentation type can be set in a replacement field by inserting a colon. Okay, so here, this says it's going to be a string. This says it's going to be a decimal number. I mean, an integer value. This is a way to convert it to binary. So you know, you can have just a number 4, and it's going to print out 100 because that's the binary version of this. And here, this is the hexadecimal, lowercase and uppercase. So if it's a lowercase x, oh, hexadecimal. Let's see. This is base 16. Base 16. So it's in you know, binary just uses base 2. It just uses a 0 and a 1. Base 10 uses 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 digits. And then for base 16, we need 6 more digits. It uses 0 through 9. That's 10 of them. But since it's base 16, we need 6 more digits, and then it starts and then the counting starts at 10. So it's all right at 10. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, 10, 11, 12, 13, 14, and 15 is the highest single digit in base 16, and that's an F. Anyway, exponential notation, these are different ways of representing numbers. And then you also have this precision thing here, this 2F, 0.2F. It's 0.2F. It's a bad way of describing it. And so this says it's a floating point number. And this is how many digits to the right of that decimal point. So the value of num as a hexadecimal base. So you do it. Since it's lowercase f, I guess you do a lowercase x. As opposed to x. What is this going to do? Ah, okay. Should have been lowercase x. And see here we just do this b, and it just displays out a binary number. It's pretty cool. All right, 416. Was there another? Okay, yeah, there's 3 challenge activities here. Okay, what's this one? Okay, we're supposed to match the format with this. Okay, so here we're printing out 25, 50, 75. Yeah, but 25, 50, 75. Oh, that's going to be with floating point. 25. No, can't mix. Here we're mixing positional, inferred positional with replacement with whatever. Anyway, you can't imply whatever. What's the term? Inferred. I'm thinking inferred or implied. When you're listening, you infer something. When you speak, you imply something. So it's kind of like we're defining it. We're stating what it is. So I wonder why it's not implied positional replacement. I guess it's because it's inferred. So anyway. Anyway, so the answer to this one is not that. It's this one. Correct. 50, 25. Okay, so it's 0, 1, 2. This is 0. Yeah, so it's this one. The 25 is there. So. And this has got, this is going to be 0.1f, 0.1f, 0.2f, 0.1f, okay, this one. Here we got this 75.01 going on here, which looks like that one. 2. If you print this out using only 2 decimal digits to the right of the decimal point, it's going to look like that. And so this must be the error. That's because you're mixing inferred and positional. All right. String formatting. Name is Alex. Right. Okay. Name is Ron. My name is Ron. Enter. I forgot to do the my name is. Excuse me. There. They changed it. Their name is Ron. And it's not, it's the gender neutral version. Okay, check. There we go. What's next? Decimal digits. May was born in 2000. May was born in 2000. Next. Okay, binary. Binary colon. 13 is 101. 1 is 11. 10. No. 10. 12 is 13. 13, comma, decimal, colon 13. Enter. All right, what's next? Weight is fish weighs that. Oh. The fish weighs 7.25 OZs. All right. We have 11 in binary is 1011, comma, 11 decimal, comma, oh, got some spaces here, 11, comma, 11.000, enter. See if that works. Yes. Okay. Let's see. We've got the first thing is color. Okay, color. Oh, 0, 1, 2. So color is green, and the adjective is big, and the thing is a car. Here we have adjective is big, color is blue, thing is bird. Yes. Okay, that looks good. All right. 423. Write a single statement to print this. User word, user number. Note that there's no space or comma. Okay. Oh, Amy 5. Okay, great. So I would do something like print. It's like, oh, Amy, comma, 5. Format, user word, comma, user number. End. Okay, so let me save this and run it. Amy, comma, 5. Amy, comma, 5. Looks good. So I bet you that's the answer. All right, last one, last challenge activity. 424, we're doing really good on time. Select the most appropriate replacement field definitions. Number of students equals 33. The math class has, oh, wants to print like that. How about, oh, start. The math class has this. Let's see. Jacob's loan rate. So this is borrower's name is the 0th one. Borrower's name loan rate is Low of 1. Okay. Very good. Okay. We want to say 3 tacos. Okay, 3 is that last one. It's number 2. Tacos for price is this middle one, which is 1. Costs total is the 0th one. It's this one here. All right. What's the last one? Okay. Tasha, name, this is N, Tasha, N, string, oh no, yeah, yes. String, N is a string, ran 3.7 because it's 1 digit to the right of the decimal point. D, and it's D, we're talking the D for distance, this D right here. And the last one is time in 4.82, so that would be 2 digits to the right of the decimal point. All right, very good. Okay, so it's 4:27. I've finished all of the challenge activities here. Just did that one. And so we're doing well here, and so I will end the lesson today, and then next Tuesday I'll go through the homework assignment, or the programming exercises at the end of chapter 3. And if we finish up if we finish those up on Tuesday, then Thursday we can start the next chapter. Are there any questions? All right, so have a good weekend, and they've extended the stay-at-home thing for another 2 weeks. So I don't know what we're gonna do, but I'm here with my daughter and my wife, and we each have our places in the house and doors shut, and so we're getting along okay. I don't see much of them during the day, but I can imagine some other people are having more troubles than us. But anyway, so stay safe, and we'll see you next time. Thanks for watching.
Thank
Thank
you.
you. Bye-bye.